Graph is a concept from mathematics highly utilized in computer science with diverse applications from computer graphics to data mining. So here is a short and basic course on graphics where we will discuss all the related basic concepts which are required for implementation of graph in any programming language will also be discussed. Knowledge of graph is incomplete without learning about the two important traversal mechanisms that are BreadthFirst Search and DepthFirst Search. So if you want to learn this concept, stay tuned.
If you haven't subscribed to our channel yet, I want to request you to hit the subscribe button and turn on the notifications bell so that you don't miss out any new updates or video releases from Great Learning. If you enjoy this video, show us some love and like this video. As it said, knowledge increases by sharing. So make sure you share this video with your friends and colleagues. Make sure to comment on the video if you have any queries or suggestions, and I will definitely respond to your comments.
Now let me tell you the agenda for the session. We are going to discuss the concept behind graphs, from understanding what a graph is to different type of graphs. We will talk about adjacency matrix and adjacency list as these concepts help in implementation of graph in any programming language. Lastly, we will discuss two of the important graph traversal and searching technique, BreadthFirst Search and DepthFirst Search, and also its implementation in Java programming languages.
Now let's see the graph data structure. So first I'll talk about what are graphs, and then we'll talk about its implementation using two different applications of graph, that is BreadthFirst Search and DepthFirst Search. So what is graphs first? So graph is actually a concept which has been derived from the field of mathematics to computer science. Okay, and graph is used here as a data structure. Here meaning in the concept of computers and programming and computer science. In this field, graph is used as a data structure. That is, it is used to store a data, represent a data in a different way. Okay, a graph consists of vertices and edges. Vertices are also called as nodes in computer science terms, but graph is basically the combination of vertex and edges. Edges connects two vertices. That is, a edge is always drawn between the two given vertex. There are different types of graphs on the basis of the different properties of vertices and edges and different properties of the graph altogether as well. But let me tell you, before going to the types of graphs, let us talk what is the different use of graph data structure in computer science. So if I talk about the application of graphs in computer science, I'll give you a very simple example. I ask you a question that, represent whoever is your friends in, like, suppose in your area or in your colony, and tell me in a pictorial way that who is a friend of whom and who is not a friend of whom, and how is that complete friendship structure in your colony or in your lane where you live. What will you do? You'll start drawing something of this type, like maybe, this is one person A, this person A is friend with person B, B is a friend with person C, and D is a person who is only friend with B. So this is how you'll represent. So this is nothing but what? A graph, where these are called as your vertices or vertex, and this is called as your edge, the line drawn between the two vertices. This is telling what exactly? The relationship between the two vertex, that is B and D. This, what kind of relationship in this example is it representing? That is a friendship relationship. So B and D are friends in the example of what right now I discussed. So in general terms also, edge between the two vertex tells some kind of a relationship between the two vertices. Okay. Another example I would give you, like suppose I ask you to, there are 5 different cities, suppose Delhi, Mumbai, Bangalore, Kolkata, Patna. And all these 5 cities, you have to travel from one place to the other. And I ask you what are the different routes I can take to travel between these cities. So what you'll do, you'll first represent these two cities like this. Suppose A, B, C, D, E. These are the 5 cities. And so, okay, you can go to B, you can go to E, and then you can go from here E to B. To go from A directly, there is a place to go. Then to go from D, you can go either directly to E or you can go directly to B. Getting it? To go to A, you have to go to C first, and then you can go to A. So this is the representation. This is nothing but a graph. Okay, so we have seen two different applications, real life example applications where a graph is used in computer science. And I hope what is graph is clear to you as of now or till now. Now let me tell you what are the different types of graphs. Although there are multiple types of graphs if I consider the field of mathematics, but I'll discuss few here which is relevant and important in the field of computer science. So first one is your directed and undirected graph, which is important for you to know. So directed and undirected graph. Okay, directed graph meaning suppose these are the vertices. There will be a edge between these. Okay, as it is a graph, there has to be edge between these vertices. Directed meaning there will be a arrow marked here. There will be a direction specified. Meaning if there is these four vertices, B is having a directed edge from B to A. Meaning there is a relationship from B to A, but the relationship whichever is between these two vertices does not exist when it is talking about A to B. It is only for B to A. Okay, so this is your directed graph where there will be some kind of direction mentioned on the edges using a arrow mark. Okay, undirected graph where there is no direction mentioned. Okay, suppose this is the three vertex and this is your graph. So there isn't any direction mentioned here. This is your undirected graph, meaning the relationship which exists between B to C is also between C to B. Right? Now there is another group of graphs called as connected and disconnected graph. What is connected and disconnected graph? Suppose all the vertices, these are the four vertices, okay, in a graph. All these four vertices are at least connected to any one of the different vertex. Any one of the other vertex, if it is connected, then it is a connected graph. Disconnected, that out of a complete graph, suppose this is your complete graph, A, B, C, and D, and these two are connected, but D is not connected to any other vertex. It's also called as your isolated vertex. So if there exists any isolated vertex in a graph, that is your disconnected graph. Or there is no link between any two vertex of a graph, that is two different graphs exist. For example, suppose there is one more edge here, one more vertex here, and this is connected. Now this complete together is one graph, okay, graph G1. But this is a disconnected graph because there is no connection between this part of a graph and this part of a graph. There are these different set of vertices where there is no connection between them. So you can divide if the complete graph into two different group of vertices where there is no edge connecting between any of the two vertices of those groups, then it is your disconnected graph. Clear? Or if there is an isolated vertex in any graph, then that is also a disconnected graph. So these are the basic classifications of a given graph. Now coming to the another concept of adjacency matrix or adjacency list. This concept is important here because when it comes to programming, adjacency matrix or adjacency list is what we use to represent graph programmatically. Okay, now what is adjacency matrix and what is adjacency list? Let's see that. So first I'll tell you what is adjacency matrix. Adjacency matrix is nothing but it will tell you that which two vertices are connected in a given graph. So this kind of a matrix, it is two-dimensional. There will be rows and there will be columns. And this represents suppose A, B, C, D, E, and F. Okay. Similarly on the row side also A, B, C, D, E, and F. Now, see, there is no self loops here. Self loop meaning if there is an edge from the vertex to the same vertex. So there is no self loop over here. So there is no self loop meaning there is no path to go from A to A. To go to A itself, there should be something like that. But there is nothing of this sort, right? So to go from A to A, there will be no path. So we'll mark it as 0. To go from B to B also no path, mark it 0. To go from C to C, similarly all this diagonal part will become 0. Now let's see from A where all you can go. You can go to B directly where you can go. Like, okay, indirectly after going to C, you can go to D also, but directly I'm talking. So from A directly you can go to B, directly to C and directly to F, only three of these, right? So B, C and F. So B, C and F will have the value as 1. Rest values will be 0. Okay. From B where all you can go either to A or to C. So A or C, rest other values will be 0. From C, where all you can go? You can go to every place like A, B, D, and E directly, not indirectly. Indirectly, you can go to F also, but directly there is no edge between C and F. So you can't go to F. So F will be alone 0. Rest everywhere we can traverse from C. Coming to D. From D, you can go directly only to C. Rest all other places, direct edge is not there between D and other edges. So D to C is only will be 1. Rest all will be 0. Similarly, from E, you can go only to F and C. So F and C value will be 1. Rest all will be 0. From F, where you can go either A or E. So A and E will be 1. Rest all values will be 0. So this is your adjacency matrix. Now, adjacency list, how is to create that? And that's what I'm going to use in programming also right now when we'll write a code for the different applications of graphs in Java. So there we'll be using adjacency list itself. Now, what is that? So it is created in this way. So all the vertices will be marked A, B, C, D, E, and F. Okay. This is column representation. And in the row, like this will contain a list alone. This will contain another list. This will consist of another list. This will consist of another list. This will also consist of another list. This will also consist of another list. This itself is also one list. Okay. And each of it is pointing to another list. Programmatically, I'm talking about. Okay. To represent it, this is column and these are the values in those columns. Now, what are the values here in this list? So whichever vertices we can reach from A directly, those will be contained in this list. So from A we can reach to B, C and F, right? So A will contain B, C and F. From B, where all you can go? A and C. So it will be A and C. From C, where we can go? A, B, D and E. So A, B, D and E. From D we can go to C only. So only C. From E we can go to F and C. C and F. From F, where we can go? We can go to either A and E directly, meaning there's a direct edge connecting between F and A, F and E. So A and E. So this is your adjacency list. Okay, that is from one given vertex, which all are the other vertices we can go. So this comprises of one list. So this is your adjacency list and this is your adjacency matrix. Now let us discuss the implementation of BreadthFirst Search algorithm. But before implementing it or writing down the code in Java, let us see what is exactly this BreadthFirst Search algorithm or how it works. So it is one of the application of graphs in which we are going to traverse the nodes of a graph in a certain order. Okay, so as the name itself says, BreadthFirst Search, that is along the breadth of a graph, along the horizontal level of a graph, we are going to search the nodes one by one in each level. So BFS is your or BreadthFirst Search is your algorithm to trace the nodes of a graph in a breadth first order. Okay, that is in a single level. First, all the nodes will be traversed, then we'll go to the next level and then next level. Now, you must be wondering whether how is the levels defined in a graph, because graph is not like a tree that you can define levels, right? So yeah, I'll tell you, if you try to visualize it like closely, you will be able to figure out that there are levels in the graph as well. So let us talk about this example itself, which is there right now here, the screen you can see. So in this, if I talk about the levels, can I consider this to be one level? This to be the another level if I talk in this order, and then this will be another level and this will be another level. Yeah. Or if I talk in this order, we can talk that this is these two A and B belongs to the same level, then F and C belongs to one level, then E and D belongs to one level. Isn't it? So you can see here that the levels, if you closely observe a graph, you can find there are different levels as well. Now, to implement BreadthFirst Search algorithm, the concept used is of queue data structure. Okay. Why I'm saying queue data structure? Before implementation, let's see how it works actually. So in that, we'll start from any one vertex. Suppose A is the source vertex to start with. So we'll start from here and go on searching along the breadth of the graph one by one. So let this be a queue. Okay. The very first vertex which you will refer or visit, that is your source vertex. So once you visit this, we have to insert that into a queue. Okay. Now there will be one more, maybe a array which will be maintained, and let that array be called as your visited array. And this will have how many indexes or how many fields to store, equal to the number of vertices. So 1, 2, 3, 4, 5, 6 vertex are there. So 0, 1, 2, 3, 4 and 5. So 6 is there. 0 to 5 is 6. So 6 nodes will be there. Whenever you will visit or traverse any given node, that will be marked here as a true. Initially all will be false. Okay. If the particular vertex is visited, that will be marked as true. So A is inserted first and it is visited first, right? So A is visited first. Okay, this 0 represents maybe A. This represents B, C, D, E, and F. Okay. We can have these numberings also like 0, 1, 2, 3. That will be more connected, I guess, or you can relate it in this way also. So this will be marked as true. Okay, it means A is visited. Now, Q follows FIFO order, that is first in, first out. So now you have to do is remove the very first element of a queue. So remove the first element, which is the first element right now, A. So A will be removed from the queue. Okay. Now, so what will be inserted? Once you remove any given vertex, we have to insert all those vertices which are in the adjacency list of A. That is, which all are connected to A. So connected to A is F, C and B, directly connected. That's what is in the adjacency list, right? So F, C and B. So we will insert here F, C and then B, right? And in this, FCB is inserted. Now next, again we will perform the same operation. We'll remove or delete the very first element of the queue. Right now the first element is F because A is already deleted. So F will be deleted, and as F is visited, so it will be marked over here. And in this also F will be marked as true because now it is traversed or visited. Which are the other nodes which are connected to F now? E and A, right? A is already traversed because this is made as true. So we'll not go with A. But connected to F is the E also. So we'll insert E again. Insertion is always from this end of a queue and deletion is always from this end of a queue, right? Okay. Next, again, same process. We'll remove the topmost element. Whichever are connected to that, we'll insert it into the queue. So C is the topmost element right now. So C will be deleted. And here the C will be marked as visited, that is true. And here also this will be your traversal list. So C will be marked here as well. And which are connected to C? A, B, D and E. So you can see A is already visited, so we will not consider A. So E and B is also already in this queue. So that also we should not insert again. Only left is D. So D will be inserted here. Fine. Next to be visited is B. Right? So B will be deleted from here. B is the next visited and B will be marked as true over here. Right? Now, which are connected to B? C and A. And already A is visited, C is also visited, so nothing is there to insert right now. Now again we'll remove the topmost element. Topmost element right now is E. So we'll remove E and E will be visited now and this will be changed to true. And as connected to E, the vertices are C and F, and C and F both are already visited because it has been converted here as a true. So we will not perform any insertion for C and F. Okay. Now next is the element to be removed is D. That's the only element left. So D will be visited now and this will be changed to true. And as now the queue is empty, will not perform this operation anymore on the graph. Okay, so this is the sequence which we get A, F, C, B, E and D in the breadth-first search. Let's see, is it following any level by level searching? So you see, first it searches A. Okay, A is this. Next it searches F, C and B. So F, C and B. Then it searches E and D. Now observe it closely. The first level comes as A, then the next level is B, C and F, then the next level is D and E. So this is your breadth first search where level wise, horizontal level wise searching is done. for any given key. Okay, and this is the order we obtain. I hope the concept is clear. Now let us see the implementation of this in Java, and for that we'll come to the IDE now and try to write the code. So yeah, here I'm using Eclipse IDE, and I've already created a class here, that is graph search. This is the file which is having a main method as well, public static void main. In this itself, I'm going to write down the code for breadth-first search, that is BFS algorithm. Logic is clear to you, so I'll go directly to the implementation. So first, what we have to do is, here we should have, so guys, how many things are required here? One is vertices, next is edges, or edges also I won't consider. The input will be vertex, that is how many vertices are there, and then the adjacency list. So we'll create an adjacency list that will tell us that related to, like for a given vertex, which all vertices are directly related. So these two will be our input, and our output will be the order in which the breadth-first search is performed. So let's write the program. So what we need first is number of vertices. Let that be denoted as V, or we can use number of vertices also as to denote. Anything is fine here. After that, we'll go here. Now, in this, I'm going to use a data structure which is already predefined in the collection framework of Java, and that is your array list. Okay, array list helps us to store or create an array dynamically. Like it grows and shrinks as the size increases and decreases. Like if you delete element, the size will decrease. So dynamically the storage, the space allocation is done. So it is more effective. Space complexity will be less. That's the reason I'm using this. You can use any other linked list or array or to implement as well. So array list, this will be of type integer. Then let it have a name, that is maybe adjacency list. So let it be adjacency. Sorry. Okay. You have to import this actually. In the java.util.star you can import, or java.util.arraylist will be have to be imported to use ArrayList in the program. Now let me have the constructor for this class graph search, because this constructor, using this constructor, we are going to initialize this adjacency list as well as the number of vertices and all those parameters. So I'm going to create graph search. Input to this will be number of vertices, number of vertex. Okay. So it will be initialized. So we'll initialize first v itself with number of vertex. Okay. Now we will also initialize this adjacency list which we created. Fine. So adjacency, this is equal to new array list. As we know that new keyword is used for allocating space to any object, and then this will be number of vertex. Okay, so adjacency list will have number of vertex as a column. The spelling correct? Let's check once. Edges. Okay. Let's have a small naming convention. So let it be ADJ itself. Okay. It will be easy to spell out. So yeah. Now the adjacency list is in the allocated space, and the size and all is declared. Now let's have the elements for it. So we'll need a for loop for this. For I is equal to 0, it will go till I less than number of vertices, number of vertex, and I plus plus. And in this we will allocate, okay, let it be ADJ itself, then I, this will be equal to new of array list. If you remember, I have told you that array adjacency list in itself is a list again. So there's one list which will have all the vertices, and then every element there is another list which consists of the list of those vertices which are directly related to that particular vertex. So that's why it's a array list over here. Fine. So these are the initializations which we have to do under this constructor graph search. So as this is done now, we'll come out of this. And now we have to insert those elements which are the part of adjacency list. Right? This is what I have created or initialized the adjacency list. Now let us actually insert. So for that we need a method. So void, let it be edge. So I'm going to add those. Why I'm giving edge here? Because between two vertex, there is an edge, right? So that edge defines that there is a relation between these two vertices. That's why the function name I've given edge. You can give anything else as well over here. It will have two vertices, int x and int y. I'm taking integer vertices, not ABCD. It will be 0, 1, 2, 3, 4 as a numbering. It is easy to work with. That's the reason. You can have character numberings as well. And then this will be adj of x dot add y. So add is a function, inbuilt function, which I'm using here that is defined inside this ErrorList class, and which will help to add the elements, add those vertices which are related to the vertex x. Okay, so this is your function for adding edges, or you can say creating adjacency list. Now let's have a function for breadth-first search. Breadth-first search. Okay. This will take input as the source vertex. The first vertex you have to give as a input to this function. So let it be source vertex. So in this, now the logic will be that we have to take that vertex, insert it into a queue or any list data structure. Okay, you can use queue, array list, arrays, anything. And there should be one visited array also, which will keep mark that which all nodes are already visited, so that we should not revisit them. Right? So let's have that written over here. So first I will create that visited vertex. It should be of Boolean type because true and false is the value we have to store here. The size will be again equal to number of vertex. Right? Or okay, we can give here as v. Both should work fine. Okay, yeah, I have missed the square brackets. Fine. Now, once this is created, we'll have another list. So I'm not using queue here. I'm using list itself. You can use queue data structure as well, which will be of type integer itself. Let it be named as A1. Short names I'm going to use now. So ErrorList again. And in this, we'll have of type integer. So these two requirements are over. Now, what we have to do is, first you have to mark the visited for the source vertex as true. Because initially, by default, it is false. So first thing I'll do is visited for source vertex to be marked as true. Okay. Now next will be we have to add the source vertex to this list A1. Add source vertex. This is what we have done, right? Even in the logic, this was there. Now, until the complete queue became empty. So here I'm using list. So until the complete list becomes empty, you have to keep doing this task, deleting the topmost one and inserting the values which are, the vertices which are related to it. We'll keep on doing this until and unless the complete list is empty, the complete queue is empty. So here it is list. So while we'll be using while loop for putting that condition. While let's have not even dot till when there is an element. So is empty is an inbuilt function which I'm going to use here to say that we have to perform this operation till there is some elements in the list. So is empty will tell you true or false, is it empty or not. So until unless it's not empty, we have to keep doing this. When it's empty, it will come out of the loop. So what we have to do is source vertex will be removed. So I mean, not source vertex will be removed. We'll remove the topmost element, that is the 0th index every time, and that will be stored. That becomes our new source vertex. And so again, the whole process will be repeated. That is first thing. And then we have to also print this. So we'll be printing source vertex. Let's have little formatting here. I'll do here print itself. After printing it, now we have to iterate over it to check that is there some more elements or not, right? Or we have to iterate over even the adjacency list to find out which are the other vertices related to this. So we need a iterator for that. And so I'm going to use the concept of iterator over here. Iterator I maybe is equal to adj source vertex every time will be made iterable dot iterator method will be called. So it is made iterable. Then we have to import this. That's the reason it's showing error here. So yeah. Now we'll have again to iterate over what we need is while loop, right? And has next method. So while I dot has next, yeah, till when there is more elements into it, what we should do, int n is equal to I dot next. Okay, we have to convert it to this integer here. Now, we have to also check that if the particular vertex is already visited, that is, we have to check that visited array. If it is already marked as true, then we should not revisit that. That condition I'm going to write now. If not equal to visited for that particular n, then we should, if it is not visited, then in the visited of n, we should mark it as true, else it will remain false. Okay, and then add that to the list. That is a1 dot add that particular node to the a1 list. That is the array list, right? So this is what the logic was earlier as well. We have seen. So this is the complete program for BreadthFirst Search. Okay. Now let us come to the main method and just write up for calling this. So in the main method, we are going to just create an object for the class. Now what is that class? Graph search itself. So yeah, graph search. Maybe G1 is equal to new graph search. And there was a constructor right over here. If you could see, where is it here? Where you have to pass number of vertices. So let's have some graph which is having 6 vertices. And then we'll be calling all the method. We'll have first adjacency list, guys, right? So edge will call and we'll define the edges now. Okay. So let us take one example of the same graph we'll take which was there in our slide. So let's go to the slide. So yeah, this was the slide, right? This was the graph in the example here. So in this, the adjacency list will be, if I mark this as integers, because integer is what we are taking. So 0, 1, 2, 3, 4, and 5. Okay. So adjacency list will be 0 and 1. We have to insert this edge. 0 is connected to 1, 0 is connected to 2, and 0 is connected to 5. So let's insert this 0 2 0 1 0 2 0 5 0 1 0 2 0 5. Okay, so similarly I'll first write this, then we'll insert the values. G1 dot again edge, then again edge, G1 dot edge, then again G1 dot edge, and again G1 dot edge. Okay, now let's see. We'll go back to the graph again. Next is your from one vertex, which all are connected, 0 is connected, and then from 1, 2 is connected. Right? So 1, 0 and 1, 2. Then similarly from 2, which all are connected, all of these except 5. Right? So 2, 1, 2, 0, 2, 4, 2, 3, and that's it. 5 is not directly connected. Then from 3, only 2 is connected. From 4, 5 and 2 is connected. So similarly, we'll insert all the pairs. Let's see. So we'll go back here. So 0, 1, 0, 2 is done. Then there was 1. 1 was connected to only 2 of them, that is 0 and 2. Right? Now next, 2 was connected to all the others except 5. So we'll insert that. 2, 0, 2, 1, 2, 3, 2, 4. It's not connected to 5. Now 3 was connected to 2 and that's it, I guess. 3 was connected to only 1. Then we'll have again some few more edges. Okay, and one more, I guess. Okay, so let's have 4 now. So 4 was connected to 2 of them, 4, 2 and 4, 5. Lastly, 5. So 5 was connected to 0 and 5 was also connected to edge. 5 was connected also to 4. So this was the graph. So this is how you will insert all the edges. Okay, so this will prepare the adjacency list. Now after once this is done, we have to call the breadth-first search algorithm. So breadth-first search, you have to pass the source. So let the source vertex be 0 itself. So it'll start from 0. Okay, and we'll now execute this and see what's the output. So the output is 0, 1, 2, 3, 4, 5. Yeah, so let's see what should be the exact output. 0, 1, 2, 3, 4, 5. So the output is 4, 5. Okay, so the output here is first 0, then 1, 2, 3, and then 4 and 5. So the output is wrong actually. The output should be somewhat similar to this, right? Level by level it should traverse. Okay, so let's check what went wrong that we are not getting the correct output. So if we traverse over the function, it was right. Let's just check once the calling part. So have we entered all the edges or not? So 0, 1, 0, 2. Let's go to the our graph. So 0, 1, 0, 2. Okay, 0, 5 is also there. Have we entered that? No, right? So let's see that thing that was the issue. So 0 and 5 will be entered. Let's execute this and check if there is something else. So now we got a different output, that is 0, 1, 2, 5, 3, 4. Okay, 0, 1, 2, 5, 3, 4. Let's see if this is a correct output. 0, 1, 2, 5, 3, 4. So yes, you can see here that 0 was visited first. This was the first level. Second level was this. Now in the second level, the order can be anything. This level, either there can be 1, 2, 5 you can visit, or 5, 2, 1, or 2, 5, 1, 2, 1, 5. all is correct answer, because it just has to traverse level by level. So this is first level. So next was this the output, then 4 and 3 was the output. So our output is correct now, right? So 0, 1, 2, 5, 3, 4. So this is the implementation of your breadth first search. So let's revisit the code once. So what we did was had a class named as graph search, where the constructor of it was used to initialize the number of vertices and also the adjacency list. And we are using the concept of array list here, which is a dynamic array, which is the concept of a dynamic array actually. And using the for loop here, we have initialized it to so the number of vertices becomes the size of this array list. Then the agency list is created, and that is done using this function edge. That is, you have to insert the edges which are directly connected between two vertices, which will be added to this adjacency list. Then the BreadthFirst Search algorithm itself, this function method itself, which will take input as a source vertex, and from this source vertex, it will traverse down alongside the breadth of the graph. Okay, so for that we need a visited uh, Boolean array, which will keep track of which node is visited, which is not, and one array list, which will keep track of which all vertices are being visited one by one, or which will help us in implementing the whole concept of breadth first search. And there is only one condition check, that till we are completely emptying it out the elements of the list or a queue, till then we should keep repeating the process of deleting the topmost one and then inserting all those nodes which are related to or directly connected to that particular vertex or node. And that's what is done. Then lastly, we need one more condition check with the help of while loop. That is, until unless there is the node is visited, we should not, if the node is visited, then we should not enter it into the list again to revisit it. So no revisiting should be there. That's the reason this while loop is needed. And that's it. In the main method, we'll just create an object of the particular class, and then call the edge function, edge method, to create the agency list. And then lastly, call the BreadthFirst Search method. So that's all about the implementation of BreadthFirst Search algorithm. Now let's see the implementation of another application of a graph, that is DepthFirst Search algorithm. So what is DepthFirst Search algorithm? First, let's try to understand that. Okay, what is the data structures that are used here to implement? Although graph itself is a data structure, but implementation of these concepts of the graph will take some other data structures that are there in the collection framework of Java while implementing it. So let's see how it is, it works and how is it implemented. So let's see the concept first. So what is DepthFirst Search algorithm? So DepthFirst Search is a searching methodology that scans through a graph depth-wise. Like vertically, first it scans all the nodes in a single depth, and then it backtraces to the previous one, the first vertex, and then it again traverses through the depth of the second line, and then again it backtracks itself, then again the next depth is traversed. So depth by depth, or in a vertical line, you can say the searching methodology continues. That is, the nodes are traversed in a depth first order. Now, what is the exactly meaning of this depth first order? Let's try to see with the help of this example here and understand. So A, B, C, D, E, and F, this is the graph. Okay. When I say depth first, so suppose this starts from here. Okay. This is your source vertex. I'll tell you the data structure which is used to implement this, and that is your stack. Okay. So we need a stack here to implement this. And then there will be again a Boolean, you can say array, which will store true or false. Initially, all the values will be false, starting from A, B, C, D, E, and F. So all the values will be false. Once we visit that particular vertex, we'll make it as true. Now, this is your how the depth-first search algorithm works. That will be explained with the help of these two data structures. But first, logically, what it is like. Okay. So depth first meaning, suppose I start from the source vertex. Okay. And I go to, so three vertices are connected to it. I can go to any depth first. I can go to F, I can go to C or B, any one. Suppose I go to F first. So I'll visit this first. Then F to F, what is connected? E is connected, A is connected. A already visited, so we'll not go back. We'll go to E now. So E is connected to C and A, B and D. So we'll go to C. Now C is connected to B and D both. So suppose I go to D now. So that's it. It ends here. Now D is no more connected further anywhere. Now it will backtrack itself till A, and then it will go to the next depth. That is, it will go to, so C it is already traversed, so it won't go to C. So it will go to B. That is your next depth. So this is one depth. I mean one line vertically down till the end of the graph, and then backtracking it to the first vertex, and then again going to the next depth. So this is what depth first search is about. If suppose I would have gone to B first, then it would have gone to this depth first till wherever it goes till the end. And then it will backtrack itself to the source vertex until then it will go to the next one. Got it? Now it's easy to understand like this when a graph is in front of you, but we have to write a program for it, right? So to write a code for it, you need to understand it in a different way. And that is, we'll be using stack over here. So what we do is that we pick up the source vertex first and insert the first vertex, that is source vertex, into it. Okay. This also what we'll do is we'll remove the topmost element in the stack, okay, and then insert all those which are connected to that particular topmost vertex. Fine. As we know that stack, we can insert also from here and we have to delete also from the top itself. So this is what will be following the pattern. So first A is there. Now first we'll delete the topmost element. Right now only one is there, that is A. We'll delete this, okay, and we'll mark this A to be visited, that is true, and A will be our first element to be traversed or searched. Now connected to A are which all? F, C and B. So you can insert this in any order. That is not important. So B, C and F, suppose I inserted. Now next element to be deleted will be F, because we delete from the topmost. So okay, F will be deleted. F will be marked as true over here and F will be placed over here as well. Okay. Now which are connected to F? E and A. A is already visited, so we'll not insert A again. Next is E. So we'll insert E into the stack. So our stack is going to look like something like this. B, C and E. E will be inserted. Right. Now we'll delete again the topmost element. Topmost element is E. So E will be deleted and E will be marked here as true. It will be deleted from here. Now which all are connected to E? Which all vertices are connected to E? C is connected. F already is visited, so no need to go there. C is connected. C is already there in the stack. So this also one condition check is that you have to check the stack also. If it is already there, then no need to insert it again. So C is already there, so we will not insert it again. Let it be like this. Now again we'll delete the first topmost element in the stack, that is C. So C will be deleted. C will be marked as true and it will be the next element to be searched. Now which are connected to C? D is connected to C. B is also connected to C. B is already inserted there. So D we will insert it again in the stack. So we'll insert D. Okay. Now we'll delete again the first topmost element, that is D. So D will be deleted and D will be marked here also as a true, that is it is visited now. Which all are connected to D? Nothing is left to be connected to to be inserted to stack because D is connected to C and C is already visited, so no need to insert it again. So will not perform any insertion here. Now next element to be deleted from stack is B. So B will be deleted. B will be marked true here, that it is visited, and B will be the next element to be searched. So this is the sequence we got. And as you can see, now the stack is empty. So until unless the stack is empty, you have to perform this operation. Once it is empty, no need to perform this operation again. We can stop there. So that will be our stopping criteria of the algorithm. Now this is what we got. So you can see here, A is traversed first, then F, then E, then C, then D, and then lastly B. So this is one depth traversed first or searched first, then the next depth. So this is your depth first search algorithm, and this is how it works. So we are going to now write the code for it, and we'll be using these three concepts itself, guys: stack and a boolean array which will store true and false, and maybe a list which will store the adjacency list, that is called as, that is which vertex is connected to which all other vertices. To maintain that, we need one array list, and then we need one stack and one boolean array. So using these three data structures, we are going to implement the concept of depth first search. So let's go to that. So we have come to the Eclipse IDE here, and I'm using Eclipse IDE to write out the code. You can use any other. Where the already I've created a class, graph search, where there is the main method of the class. So we'll be writing down the code in this itself for depth first search. So let the main method go to down. Okay. So as I've told you that we need three different things here. One is here the concept of stack. Then one we need a Boolean array to keep track of which all nodes are visited, which are not. And then one more list that is your adjacency list. So let's create all these. So first will be the number of vertices, which will be denoted in the with the help of variable v. Then we'll have a array list, which is of type integer. This is will be maintaining the adjacency list. Okay, you can give any name to this, which is an array. So if we can give maybe adj. Okay, I think we have to import the class. So yeah, let's import it. And this should be the wrapper class. We cannot use primitive data type over here because all these classes which are defined in the collection framework takes wrapper class to be the data type for it, not the primitive data types. Now we have to create the constructor for the class graph search so that we can initialize how many vertices are there. Also, we can initialize the adjacency list. So let's have the constructor here for the class graph search, which will take input as number of vertex, which will take as a parameter. So it is a parameterized constructor, which is taking one parameter, that is number of vertices. So we'll initialize v with this number of vertex. Then we are also going to add, initialize the adjacency list, new array list, number of vertex will be its size. Okay, this will be a square bracket here. So yeah, this is done. Now let's create the structure for the adjacency list. Like we created an array list where all the vertices are there, but each vertex should be connected to a list that is called as adjacency list, to which that will represent that that particular vertex is connected to which all other vertices. So that's what I'm going to do here. That is int I is equal to 0. And then I should be less than here number of vertices. And it will go till I plus plus. And then here I'm going to initialize this. This is equal to new array list. Okay. So this is done. The constructor for the graph search class is created. Closing. This is also closing. Now we have to create the elements inside this adjacency list. That is the edges which are there that should be inserted. So for that, I'm going to create a method void edge, which will take two parameters, int x and int y, and which will be inserted into this adjacency list. So adjacency of x will be having, you have to add y here. So add is an inbuilt function which is being used. It is inside the collection framework, or you can say it is inside ArrayList class. So that's it for adding the values or edges to the adjacency list. Now we'll write down our main function of DepthFirst Search. Okay, it will take input the first source vertex. Okay, let it be source vertex as a name. Now, in this, the logic is we have to use stack, we have to use Boolean array. So let's define first all those whichever is needed. So Boolean array, maybe the name will be suppose visited. Okay, the size will be equal to your number of vertices. We need a stack now. So how to create a stack? We have to use inbuilt stack class and create an object for this. Okay, let it be S1, which is equal to new stack. Then we have to import this, I guess. So let's import it. In the java.util package, it is there. So we have to import that. So now stack and this visited array is created. Now we have to come to the logic. So every time we should peek into the stack and see which is the topmost element, then pop it out, delete it out, and then go to the adjacency list, and whichever is connected to that, we should insert into the stack again, and then perform the whole operation. So let's write the logic for that part. So s1 dot, first you have to push the source vertex, okay, and also change its value in the visited to true, because initially it will be false. Okay, let this be represented also as a node. Now the condition check will be there. So while there is some element in the stack, we have to keep doing this. Okay, it should be s1 dot empty. Yeah, so empty is a function which we are going to use. So till the stack is not empty, we should keep continuing and doing the process of deleting. So that will be s1 dot pop. Okay, but before this, what we should pop? So for that, you have to peek into the stack, right? So your source vertex will become now whatever you peek into the stack, right? And then you should pop out the topmost element. Okay, so while loop is completed here. Now we have to do what? Check the adjacency list, whichever are there that has to be inserted, and also we have to keep a check that the visited vertex, visited node should be marked as true, or it should be false first, then only we can insert it. So let's write the code for that. So for int I is equal to 0, adj of source vertex should be uh, its size. So yeah, size is the function there. We can have that till the size of it, like complete list you should scan. Okay, should be I less than. Now here your node will become adj of source vertex, adj of source vertex dot get function is will be used, get of I. Okay, so get of I will tell you that particular at that particular index, whatever is the value it gets you, like it fetches that value, because that's what we'll be comparing, right? Is it inserted first or not? Now here we have to also keep a check that in the visited uh, array, it should not be true. It should be false. If it is true, it means it is already visited. So that check should also be done. So s1 dot push. If it is not, then only we should perform push. And what we should push? Node, whichever node we are referring that time with. Okay. Now, okay, this is closing here for loop. Okay. Now we will do the changing of true to false. So if visited source vertex uh, is equal to false, then we should change it to true, right? Visited source vertex should be changed to true, and also it should print. Nowhere we are printing, so let's print it here. So we should print what here? Source vertex, because that is the vertex being visited that time. Okay, and we'll change it to true. So that's it, I guess. This is the ending part of it. This is end of the function. So yeah, this is our depth first search algorithm. Let's call this in the main function now. So to call it, we have to make an object of class graph search. So let's make it quickly. Graph search G1 equals to new graph search. So to pass the source vertex should be passed over here, right? Okay, no, the size of it. So size, let's take the same example which we have to taken for the explanation. So in the explanation, if we go, you can see this is the graph. So it is connected to A to B, A to C, A to F. So we'll insert all these values here. So let's call G1 dot edge. G1 dot edge. Okay, I'll copy paste it. Let's save some time. So how many edges are there? 1, 2, 3, 4, 5, 6, 7. 7 edges are there, right? Okay, let's go back. We have inserted so many. Okay, let's insert the values of it and see. So 0 is connected to 1, 0 was connected to 2. Then 1 was connected to all except 5, we remember, right? So 1 is connected to 0, 1 is connected to 2, 1 is connected to 3, 1 is connected to 4. So yeah, let's see. I think 2 was connected here. So yeah, if I represent this with numbers like 0, 1, 2, 3, so it will be something like this. This will be 0, 1, 2, 3, 4, 5. So 2 is connected to all except 5. 1 is connected only to 0 and 2. 1 is connected only to 0 and 2. Okay, my mistake. 2, 2, then 3, and then 4, again 4, then 5, and again 5. So yeah, these are the number of, so 1 is connected to 1, 0 and 2. 2 is connected to 1, 0, 3, 4. 3 is connected to, I think, only 1, which was 2. 4 is connected to, let's check, guys. 4 is connected to 5 and 2. And 5 is connected to 0 and 4. Okay. So 4 is connected to 2 and 5. 5 is connected to 0 and 4. I hope this is right. Okay. Let's call the function g1 dot depth first search and pass 0th index there. Let's have one print statement as well here, stating that result of depth first search. Okay. Okay, so it is not printing correct. Again, there is something which we have missed, so let's check it out. Okay, so as we are checking what went wrong, so we'll see here depth first search, it's correct, source vertex stack, then we have to push it to it, then this node will refer the current no vertex being visited, s1.empty source vertex, then we'll pop it out. Size, okay, till the size of the adjacency list, we have to traverse it all and then push it into it. It's false. Okay, it's looking correct. Let's figure it out. So I think, okay, okay, this while loop should not end here. It should end over here. Let's see if it works. Okay, yeah, so that was the problem. We have closed the while loop over here itself. So it should be closed at the end. So this is the output of the depth first search 0, 5, 4, 2, 3, and 1. So you can see this is also the output. We can match it with what output we got. So it is 0, 5, 4, 2, 3, 1. 0, 5, 4, 2, 3, and then 1. So it's correct, right? This was one depth, and then this was the next depth. So 0, 5, 4, 2, 3, and 1. So yeah, our output is correct for this program. So you can see, just I'll go through the code once again. So what we did was we created a depth-first search function here. Before that, adjacency list was created, and the edges which were connected were added to that adjacency list. And then while searching, while performing depth-first search, we have to keep no we have to use these two data structures, the stack and one boolean array, which will keep track of whether the node is visited or not. And that's what is done. We have to peek into the stack, whichever is the first element, we have to delete that, and whichever is connected to that particular deleted vertex, insert all that to the stack, that is push all that to the stack, and then also check if it is the visited vertex value is false or not. If it is false in the visited array, then should make it true, and that will be printed also as an output. And then in the main function, we have created the edges, that is the adjacency list is created, and then the depth first search method is called, and that will give us the desired result. So this was all about the implementation of your depth first search algorithm.
Let's summarize the course. We discussed what a graph is all about, few basic types of graph which are relevant to implementation of certain graph traversal algorithm. We also learned how to create an adjacency matrix from a given graph. Adjacency list is a concept required for implementation of graph-based concept in any programming language. So we talked about how to create the adjacency list as well. Then the logic of the traversal of the graph through BreadthFirst Search and DepthFirst Search was discussed. The implementation of these concepts using Java programming was also discussed. I hope you find the session useful.
If you haven't subscribed to our channel yet, I want to request you to hit the subscribe button and turn on the notifications bell so that you don't miss out any new updates or video releases from Great Learning. If you enjoy this video, show us some love and like this video. As it said, knowledge increases by sharing. So make sure you share this video with your friends and colleagues. Make sure to comment on the video if you have any queries or suggestions, and I will definitely respond to your comments.